Thanks, everybody. It's nice to be here today. Many of you probably know Electrify by its precedent company, which was Opera Solutions. And we are the oldest machine learning company in the United States of America. And we're here to talk a little bit today about how to make money with this data, which is what we do for a living every day. We are, to level set for those who don't know us, using the Data Science Salon as the global rebrand of our company into Electrify. So we're super excited to be able to do that today. We are approximately 260 some odd individuals across 5 offices around the world. And for us, machine learning is practical. It's transformative and it's scalable. It's about making money. And we've heard a lot about technologies today, some visions into the future, but sometimes I think it's helpful to sort of bring it all down into a more tangible, relatable way. When we go talk to some of the world's largest corporations that are our customers, Johnson & Johnson, United Airlines, the Center for Medicaid and Medicare Services, Tenet, many, many others, Norwegian Cruise Lines, we talk about how to make machine learning relatable and practical. And what we find, actually, I'm probably a little bit older than many of the people in the audience, what we find is that there's a great insecurity and ambiguity about how does this machine learning actually get incorporated into our workflows to make money? Who can do this for us? Well, we can. We've been doing it for 10 years for many of the world's largest corporations. We're probably the only machine learning company right now that is actually profitable, making money, producing cash. So let's talk about what the big problem is in machine learning that we see. And I'm sure many that were articulated today are also very valid. But what we see the big problem being is how to actually do machine learning at scale. It's easy to do it with one data scientist, or a software engineer serving one problem or writing one model. But how actually do you do this at scale? And what is the fundamental problem? As we see it, the fundamental problem really is getting at this data. It's everywhere, and it's all kinds of different things, as many of the speakers have already mentioned today. It's structured, it's unstructured. It's in blogs, it's in tweets, it's in point-of-sale systems, it's in CRM systems, it's just kind of everywhere. So for Electrify, what we do is we are that intelligence layer on top of all of these distributed data systems. And for the first time in our lives, we're able to pull that out. And what we do is we prepare that data for machine learning. That's what we do. And it's really hard. And anybody who doesn't tell you that doesn't know what they're doing. It's really hard. For all of our customers that we truly, truly value, and it's a privilege to serve, that data comes to us like Swiss cheese. Sound familiar? It's empty, it's wrong, it's coded wrong, it's misfiled, it's in every single possible format, every possible problem known to mankind. And we make sense of that chaos. And we use that data, that transformed data, in a way that our machine learning scientists and our data scientists turn into insights, as many of you have been talking today. But that problem that we're speaking about of the extraction, the transformation, the Wall Street Journal and Silicon Valley all want to talk about AI and ML. I'm not even sure they know the difference between AI and ML. Many of our customers don't. Probably many of the people in the companies that you all work for have that same ambiguity, and that's okay. They're not supposed to. But at the end of the day, we have to actually take all this data and turn it into something, turn it into an insight. And that's where it gets very, very tricky. And for one of the world's largest insurance companies, we deal with 500 terabytes of data every day, turning all of that disparate data into personalized marketing campaigns for the different aspects of the insurance company, whatever the different disparate customers are. That's really hard. And that's where the rubber hits the road, and it's where the winners are separated from the losers. So how do we do this? And maybe we'll just I'll show you an architecture of how we do this, and then maybe a little case study involving T-Mobile, and we'll share some real numbers with you guys. And the T-Mobile example is a good one. We're focused really on three verticals for us as a company: the government, healthcare, payers, providers, and consumer. And a lot of that's in media, so it's really apt for us to be here today. And we focus on three real solutions, which is what we call brand AI, which is customer activation, retention, and development in machine learning. Am I having my Bill Gates moment? That's okay. Well, we don't really need it. So the three solutions for us are what we call brand AI, customer activation, retention, and development in machine learning, procurement AI, and contract AI. Really simple, what we call boring stuff affecting every single enterprise here. So how do we do this? How do we handle terabytes and terabytes of data? We do it on an open unified computational engine. We do it using notebooks, Zeppelin and Jupyter. We let our data scientists and our clients' data scientists code in whatever language they want. And we let them access that data and store that data wherever they want, whether it's on the cloud, a relational database system, Netezza, in their backyard, we don't care. The point of this is to make the data accessible and usable by those who need to in order to empower and drive their own enterprises forward for whatever the practical solution or the practical issue is. But how we really stand this up for our customers is we are able to take this data and stand up a solution in weeks, 4-6 weeks. How do we do it? In the areas that we choose to focus in consumer, government, healthcare, we really understand the problems that these enterprises are facing, and they're common. And we take those problems and we drop them into containers and Dockers. And with Kubernetes, we're able to actually orchestrate a way to reuse that so that our clients get the benefit of all that's come before them, to stand up time to value quickly. Because who wants to go to the CEO or the CFO or the CPO, whatever, or CMO, and essentially say, yeah, this is a really great idea, we're going to do it, and we're going to do it over the course of the next year. You're going to get a lot of, I don't think so's, or we'll see whether we had budget for that. So we try to solve that problem. Once again, practical, transformative, scalable. Use the Dockers, the containers, the Kubernetes, the componentized logic, reuse it to stand up solutions quickly in the areas where we are. That's how we do it. So let's take an example. T-Mobile. What do we do for T-Mobile? Great brand. And any media company ought to be thinking about this. By the way, I should just, one shameless pitch. We won the Netflix contest years ago to create, out of unsupervised learning, their recommendation system that we all use every single day. Really hard. Really hard. T-Mobile, what do? They give us 55 million customer accounts every 2 weeks. It's a lot. We batch process this, in this particular case. And that customer data is run through our models, which discern the propensity of those customers to churn. Anybody who's in the media business here today ought to be listening to this. There are only two numbers that matter in the entire media business. What's my cost of customer acquisition, and what's my churn? You get them right, you got a business. You get them wrong, the bank owns your company. That's the way it is. They trust that data to us. We give them back a list of the customers that have a high propensity, high likelihood to churn. And they turn their marketing engines on that. Whether it's at Metro, prepaid, postpaid, the regular T-Mobile, doesn't matter. They ask us for the algorithms. We tell them that's not in the original SOW, but we can talk about it. But this is real value. So what is the real value? Okay? They know. They're okay with us saying this. It's $150 million a year. of real value, just for them. They pay us a lot less than that, sadly. But that's real, that's tangible, that's practical. This is practical AI. So we can talk about theory, science, the future, ethereal stuff. We want to talk about making a difference today, because my job depends on it, and I suspect many of yours do as well. And that's what we try to, this is what we try to do. And at the end of the day, this is a really interesting phrase at the end here. We actually give them the ability also to take tremendous amounts of data out of their call centers, out of their stores, out of their website, and sit almost in a control tower, air traffic control tower type position and say, what is this data telling me? What if I want to run a campaign for some demographic in Texas or some demographic in New York, or target somebody else on the business side for business users? We give them the ability to sit at the control tower and operate it themselves. That's practical, transformative machine learning. That's what we do for a living. For J&J, one of the largest pharma companies, we run their entire $15 billion global procurement system in machine learning. We give them the ability to figure out where all their rebates and discounts are that they never got. They asked us to create something called Contract AI, which we're unveiling to the world. It sits across their 150,000 contracts and lets them pull up key terms, words, and conditions on their iPad, phones, or laptops to tell them, what are the critical termination provisions? What are the critical issues in a contract? So this is what we're all about, turning data essentially into insights and money for our clients. So with that, perhaps I'll close and maybe take some questions.
In the T-Mobile case, what were the different types of feeds that you potentially got in order to make one of the things in this whole machine learning AI paradigm is the more dimensions that you have, the better your prediction model becomes.
The more data.
The more dimensions or different sources,
Yeah.
right? Yeah.
So we grab data from everywhere from T-Mobile, literally from everywhere. We grab it from the web, we grab it from the call centers, we grab it both voice and data. We grab it from the retail stores, and we paint a picture of the customer. And with that, because we have so much data every 2 weeks or every 3 weeks, we can get a pretty accurate picture of how people are acting, what they're saying, what they're doing, who has that propensity to churn. Whether their problem is drop calls, whether their problem is the data plan stinks, whatever it is. And so that, because they give us so much data, we have the ability, and we've worked with them for a long time, we have the ability to actually pick out who are, for lack of better words, who's likely to have an issue and who should get a targeted marketing campaign, a personalized marketing campaign. And that's actually pretty interesting because I think, all of these subscription-driven businesses and so forth, if you don't know your customers really intimately, and if you're not touching them on the web and tweets, blogs, sentiment analysis, at the stores, on whatever, you're at real risk for losing them. And the problem with the media business is that every capital structure is virtually, they're all leveraged. So if you miss this, if this gets messed up, this is a real problem. The churn is an enormous problem. So we try to help them with that. I hope that answers your question. Yeah, sure. I think it's a great question. For the United States government, we do an awful lot with regard to various agencies. How about that? And so all of that data stays onshore in protected data centers and so forth. For the Chinese government, for Ping An, which is one of our largest customers, all that data stays in the PRC. So yeah, we are hypersensitive about, about the policies, procedures, methodologies, and security, around that data. So it's a part of doing this business.
Yeah, sorry.
No.
Let's say you access all the text messages and go through all the numbers, so it's just
It's very sensitive because really what we're doing is at the end of the day with all this data, we're stitching, we're connecting, integrating, stitching together, and then lightning. So yeah, they're very, very sensitive issues, and we take this very seriously. Thank you.
Is there anything you can share about the Netflix experience?
40,000 people competed, one firm won. They were good. It worked. They paid us some money. I think I'll answer it this way. The United States government came to us and said, we have a problem. We have a problem with men and women returning from the battlefield, engaging in aberrant behavior, suicidal behavior, real trauma. We've been looking for a long time to solve this problem. There's no ground truth. Sounds like Netflix. Netflix gave us less than 1% of their data, their user data, less than 1%, and said, someone divine us a recommendation engine. So that experience, I'll answer your question this way, became the foundation for us to tackle a very difficult problem for the United States government, which it's an honor to do.
Thank you so much.
What's the last 10 years? You mentioned that you're one of the only profitable kind of AI companies.
Yeah. ML. There's not a lot of AI in what we do. Yeah.
What's kind of any tips or strategies in terms of balancing, R&D, and then also, consultation and obviously consulting hours? Like, is there any thought or concern about being profitable now but not profitable?
We worry about being self-sustaining from a cash perspective all the time because the best businesses in the world pay for themselves and don't have to rely upon the largesse or the venture capitalists in Silicon Valley or the private equity folks. We're worried about it all the time. And our value proposition of standing up a solution quickly in 4 or 5 or 6 weeks, as we described, we get a lot of knowledge reuse and a lot of operational leverage from the use of containers and Dockers and so forth and that logic. That's number one, the operating leverage in our model. Number two, we get a lot of operating leverage offshore as well, where we can put solutions into maintenance mode for people quickly and get that done and get some of those costs offshore. So that helps us. But it's all about getting to the customer quickly, standing up the customer value, time to value for the customer. That's the thing. Demystifying this stuff called ML, making it real and what's more practical than procurement, contracts, or customer retention and development and activation? This is kind of the heart of most businesses, or fraud, waste, abuse, whatever. There's money in this stuff. And the government tells us, we have a skills shortage in ML. Can you guys help us? I think that's true with a lot of companies as well. So we try to make our value proposition attractive to them, attractive to us in such a way that we can create a long-term partnership. But we're very focused on controlling our destiny with the production of cash. It's hard. If we decided to grow, yeah, you're right. We'd blow through a lot of money. But we're more judicious on that, a little bit more prudent, choosing the folks with whom we work. We want 10 customers like T-Mobile, whether they're right now. I'll give you a sense. We're building a large esports effort. Okay, so you'd say why? Well, there's 400 million people doing it around the world, and yes, we could go, do work for one of the studios, and we would love to do that. But this is pretty exciting. 400 million people going to 1 billion. This is cultural. Everybody in here, or probably 80% of the people in here, have tried a game or play a game or like to go watch on Twitch or something like that. We're capturing that data, turning that data into insights for some of the world's largest brands. So we have to innovate and keep going and use the technology to give ourselves operating leverage and use our resources offshore. But it's a great question, because all this is about making money. We have to pay the bills.
Thank you so much. We're at time.
Thank you.
Thank you so much.
Yep.